Okay, good day everyone. So this video is about buoyancy. So buoyancy is defined as the upward net force on objects within a liquid. So if you will recall, if an object is submerged in a water, in a body of water, the object experiences pressure on all directions. So in this case, buoyancy is the upward force that the object experiences. So this occurs because pressure in a fluid increases with depth. And since the bottom is deeper, more force is pushing up than force on the bottom pushing down. So the force on the top is minimal compared to the force from the bottom. So that upward force from the bottom is called buoyancy, and this is what pushes the objects up. Okay, so this is a diagram of how buoyancy works. So you have there an object. So the upward force is the buoyant force, while there is a downward force called due to gravity. Okay, so this this force was discovered by Archimedes, and um, it gave birth to the Archimedes principle. So, Archimedes principle states that the buoyant force on an object is equal to the weight of the fluid displaced by the object. So, buoyant force is equal to the weight of the object, which is weight is just your mass times the gravity. So you may also recall that density is equal to mass over volume. And so we can rewrite that as mass is equal to density times volume. So therefore, your buoyant force is given by rho V times G. So rho being your density, V being your volume, and G is being your gravity, acceleration due to gravity. So it is important also to remember that it is not the object that exerts the buoyant force, but it is the fluid that the object displaces that causes it. So this is your formula for the buoyant force. It is given by FB is equal to density of the fluid times the gravity times the volume of the submerged object. Okay, so this buoyant force determines whether an object sinks or float. So the difference between the buoyant force and the object's weight determines whether an object sinks or floats. So if the um, if the buoyant force is greater than the object's weight, then the object would float. But if the weight is greater than the buoyant force, then the object would sink. Okay, so here is this is how Archimedes they found out about the buoyant force. Okay, so here this is an example. Okay, this is how he found out about it. So, a 70-kilogram statue lies at the bottom of the sea. Oh, I'm sorry. Next example pa di ay. Okay, so example 1. So, a 70-kilogram statue lies at the bottom of the sea. Its volume is 3 times 10 to the power of negative 2 meter cube. So, how much force is needed to lift it? Okay, first we have to list the given. So we have the mass of the object, which is equal to 70 kilograms, the volume of the object, which is 3 times 10 to the negative 2 meter cube, and we also have other stuff that aren't listed in the problem, but we should already know. So the density of water is 1030 kilogram per meter cube, or 1.03 times 10 to the power of 3 kilogram per meter cube. And we also have gravity, which is equal to 9.8 meter per second squared. Okay, so what is asked? So, we are asked to find how much force is needed to lift the statue. So let's say this is the statue. We have 70 kilogram statue. So what are the forces acting on it? So this is the part where we draw our free body diagram, or FBD. So this helps us visualize what forces are acting on it, which direction the forces which directions are the forces, and yeah, generally this makes it easier for us to visualize how to solve the problem. So what are the upward forces acting on the statue? So we have the buoyant force, and the downward forces acting on the statue is the force due to gravity. Now, what should we do next? So, we must find the formula on how to find the problem. So, since we are looking for the force, then we are going to use this. So, the F net, or your summation of forces, is equal to FG minus FB, since they are on opposite directions, so you must subtract it. So in this case, in this problem, I set the kuan kaning sa FG, or your force due to gravity, as the positive one. So if kana siyang positive, then your buoyant force would be negative. So that is how I oriented my sign, but you can do it on your way. You can assign the signs in which way that makes sense to you. So in my case, this is how it made sense to me. So yeah, um I made the force of gravity the positive one. Okay, so note. Okay, so Fg, or your force of gravity, is just your mass times the gravity. Okay, your mass of the object times the gravity, and your buoyant force given earlier is just your density of the fluid times the volume of the submerged times g. Okay, so next. So since we have that, we are going to substitute those in the first equation. So Fg, the second equation would become um, F net is equal to mass of the object times gravity minus density of the fluid times volume submerged times gravity. So since present ang gravity sa both equations, then we can just factor it out, and then it would become F net equals G times mass of the object minus density of the water times the volume of the submerged. Okay, next, since we found the formula, we are going to substitute it. We are going to find, or we are going to solve the problem. Okay, so now our formula is F net equals G times mass of the object minus density of water times volume submerged. Now, nga ng water man dire? Sa fluid na to, ang formula for buoyant force is the density of the fluid. But since in our problem, um, it is stated that the statue is at the bottom of the sea, then I assume that the density ang fluid na gigamit is is for the water. So wala siya nga nahimo na siyang water. Okay, so but it can be other liquids, it can be alcohol, it can be oil, mercury, or anything, but there is atong problem, water ang atong gigamit. Okay, so then substitute those quantities from the given, then you should get your force is equal to 383.18 newtons. Okay, so please verify na lang na later in-review ninyo sa inyong notes. And so we should write the answer, which is the force needed to lift the statue is 383.18 newtons. Okay, so here is another example. Example number 2. When a crown of mass 14.7 kilogram is submerged in water, an accurate scale reads only 13.4 kilograms. So is the crown gold? the specific gravity of gold is 19.3. So this is how Archimedes solved this problem. Okay. Actually, you should read, no, or you should read how Archimedes giunsa niya pag find out or giunsa niya pag come up sa buoyant force nga koan. Yeah, giunsa niya pag come up sa buoyant force because it's very interesting. Okay, so this is the problem. Then first we are going to list what are the given. So um, for the given, let M be the actual mass such that M is equal to 14.7 kilograms. And let M prime be the submerged mass such that M prime is equal to 13.4 kilograms. And um, since the volume, since the fluid used is water, then we are going to use the density of the water, which is equal to 1030 kilogram per meter cube. Now, what here is okay, what we're going to do next is visualize the problem and draw our free body diagram. So, according to the problem, the mass of the mass outside the crown weighs 14.7 kilograms outside of the water. So that is its actual mass. When it was submerged in water, an accurate scale reads only 13.4 kilograms. So naano siya sa tubig. So what are the forces acting on the crown katong wala pa siya gisulod sa tubig? So okay, who can guess or like yeah. So, think for a moment kung unsa kayo ang forces nga nag-act ana. So, if you thought nga FG lang, then you are correct. So, the force acting on the crown outside of the water is only the force due to gravity. So, how about Derisa when it was already submerged in water? So, what are the forces acting on it? Okay, so the first one is what are the upward forces? So nanatay upward force because it is already submerged in water. So first is we have the tension force. We also have the buoyant force. Okay, so downward force pod ani is we have the force due to gravity. Now what is asked? Okay, so the way to find out whether the crown is gold or not is actually to find the specific gravity of the crown compared sa water. Okay? So the formula is we must remember that F is or the force is equal to MA. Okay? And then F net is equal to F force, tension force, plus the buoyant force. So, plus sila duha because they are on the same direction, minus the force due to gravity. So, it will become Ft plus Fb minus Fg is equal to Ma. But since wala man tay acceleration nga nahitabo dire, we can just equate it to 0. So, mo na siya formula, Ft plus Fb minus Fg equals 0. Ano ganing na 0 na siya? It's because walay acceleration nga nahitabo. Okay, they are stationary. Okay, so next. Ako ang nahitabuan ni diri is transfer lang nako ang tension force and then I equated it to the force due to gravity and the buoyant force. Okay, you can actually rewind it or sa inyong notes. So the equation would become Ft equals Fg minus Fb. Okay, so this is actually just your Fg is just your weight, 'di ba? Force due to gravity is just your weight. So, ato na siyang i-equate. So, let's your Ft or your tension force is your W prime or your weight nga submerged. So, this is equal to your Fg is your weight, your actual weight katong wala pa gi-submerge ang crown, minus the buoyant force. Okay? So, now, atong itapad ang duha ka weight. So, mahimo siyang FB or buoyant force is equal to W minus W prime. Okay, so let's label that as equation 1. So, remember, your Fg or your force due to gravity is your weight, and your weight is equal to mass times gravity. Let's label that as equation 2. Now, your buoyant force is equal to m of the fluid times g, which is equal to density of the fluid times the volume times your gravity. So, ato na siyang kuan, like label as equation number 3. So, paunsa man nato na siya makakuha ang kuan. Oh, sorry. Okay, so paunsa man nato to makuha tong atoang specific gravity. So, we are going to atong i-ratio ang equation 3 og ang equation 1. So, we get W, ano na W man na, ang equation 3 is W over W minus, oh, nabali. Okay, atong i-equate ang equation 2 rather. So, instead nga 3 na siya, it's equation 2. 2 versus 1. So, we get W over W minus W prime. Your W is just your mg over F buoyant force, which is equal to, ang mg nato kay equal to the density of the object times the volume of the object times the gravity, and your buoyant force is just equal to the density of the fluid times the velocity times the volume times the gravity. So, since same man ang Vg na siya sa numerator o denominator, then we can just cancel it out, and ang nabili na lang is the density of the object over the density of the fluid. Now, does that look familiar to you? Okay, so that is actually the specific gravity. So remember, di ba, ang formula sa specific gravity is the density of the object over the density of the water. So, since mo man na siya, ibalik na to tong kuan, ganina kaning W over W minus W prime. So, your W is just your weight, di ba? So, we can equate that to mg over mg minus m prime times gravity. Kanang m prime, if you remember sa atong given, ato na siyang gilet, di ba? That is your mass when it is submerged in water. So, since na gravity sa tanang kuan, numerator or denominator, we can cancel it out. So, ang mabili na lang is m over m minus m prime. Okay, so that is equal to 14.7 kilograms over 14.7 kilogram minus 13.4 kilogram, which is equal to 11.31. Now, the answer. So, the specific gravity of the crown is equal to 11.31, which means that the crown is not made of gold. Kay ang specific gravity sa gold kay 19.3. Okay, so next, let's go to floating. Sama ng floating. Okay, kabalo po tanan no. Okay, floating, an object floats on a fluid if its density is less than that of the fluid. So kung kuan, musink na siya kung more than sa fluid ang iyang density. So when floating, the buoyant force is equal to the weight. So ato na siya i-break down. Ang buoyant force is your raw F, the volume of the displaced, and G. So, ang formula for floating, or your formula for your partially submerged objects, is just this one. The density of the fluid times the volume of the displaced or volume submerged is equal to density of the object times the volume of the object. So the fraction of an object submerged is given by the ratio of the density of the object to the fluid. So here is an example. A rectangular block of wood na siya dimensions, floats so that 0.15 meter of its height is above the water level. Letter A, find the density of the wood. And letter B, find the mass of the wood. So, kaning nga problem, so, partially submerged lang ang fluid. So, dili siya pareha sa atong previous nga examples. So, how do we solve this? So, first, we have to list the given. So let V be the actual volume of the block such that V is equal to kana siya dimensions. I-multiply nimo na siya tanan, it is equal to 0.5 meters. And let V prime be the submerged volume of the block such that V is equal to 1.0 meters times 2.0 meters times 0.10 meters, which is equal to 0.2 meters. So, nganong kuan man na siya? Nganong nahimo man ng 0.10 meters? Kay, giminus na to ang kanang 0.15 meters nga wala na submerge sa tubig. Okay? So, another thing is, since sa water man siya, we have the density of the water which is equal to 1,030 kilogram per meter cube. So, next is we are going to visualize that. Okay, so naadaw na siya sa container. And then, kanang nasa tunga ka ng rectangle dira, that is your block of wood. And it is just partially submerged in the water. So, what are the forces acting on it? So, unsa man kayo ang upward forces ani? Okay, I'll give you a moment to think. Okay, so if you thought nga the upward forces acting on your block of wood is just your buoyant force. So how about the downward forces? What are the downward forces acting on it? So of course, it is always not tayo gravity nga mag-act all the time. Sa downward force, di na siya nagid ng force due to gravity. Okay, so now let's i-mathematics na to ang formula. Okay, so like your force, ang formula for your force is equal to MA. So, kaning sa tong problem, what are the forces acting on it? We have F net is equal to FG minus FB. So, nganong ing-ana man na siya? Okay? Because those are your forces acting on the block of wood. So, FB minus FG. So, kanina po nga problem, ako ang giset ang force due to gravity as positive. Okay? So, Fg minus Fb is equal to ma. But since ang atoang acceleration is 0, so we can just cancel ma out, and you are left with Fg minus Fb is equal to 0. So, next is just ibalhin lang nato ang isa. We have Fg equals Fb, or your force of gravity is equal to buoyant force. Okay, next. So, recall that your force due to gravity is equal to mass of the object times the gravity, and your buoyant force is equal to the density of the fluid times the volume submerged times your gravity. So, ato na siyang i-substitute dito sa ato ang equation, then you will get mass of the object, or MO, times your gravity is equal to density of the fluid times V prime times gravity. So, nganong na V prime man na siya? So, if you recall, dito sa given nato, we let V prime be the volume of the submerged block of wood. So, mo na siya nga, nahimo siyang V prime. Kaya para convenient ra pud sa ato dili na ta sulat og V sub ana. So ato na siyang giset sa given nato as that. But okay ra pod if ang inyong gamiton jud is kaning nasa recall nga formula, which is um, density of the fluid times V sub times G. Okay, so after that, since na may G sa both sides of the equation, we can just cancel it out, and ang mabilin na lang dayon is MO, or mass of the object, is equal to the density of the fluid times V prime. So recall na pod, no, our mass is just equal to density times volume. So, since ingana mo na siya, atong i-replace ning sa left side, which is your MO, ani nga equation. So, it would become density of the object times V is equal to density of the fluid times V prime. Nganong kuan man, nganong V man na siya. So, once again, atong giset ang volume, volume ang V as the actual volume of the object. Okay, so i-ratio na to na siya if kuan na katong nasa previous nga slide, I think slide 10. So if we ato na siya ibuto into ratio, may more siyang density of the object over density of the fluid is equal to V prime over V. So kana siya na ratio is just the relationship between the density and the ratio submerged. So that is your kuan. Mo na ni siya ang atong formula nga gamiton. So now let's go to the solution. Okay, so letter A. So the density of the block of wood. So okay, we used that formula. So density of block is equal to the density of the fluid, which is sa atong problem is water. So density of water times V prime over V. So this is equal to, ang density sa water is 1030 times ang V prime kay 0.2 meter cube over ang actual volume is 0.5 meter cube. So you should get 412 kilogram per meter cube. So since na naman tayo density, we can easily calculate the mass of the block of wood. So mass is equal to density times the volume. So density of the block is equal to 412 kilogram per meter cube times your V, or the actual volume of the block, which is 0.5 meter cube. So you should get 206 kilograms. So now list the answer. So the answer is the density of the block of wood is equal to 412 kilogram per meter cube, and the mass is equal to 206 kilograms. So, nganong kuan? Kaning diri sa tong formula, nakuha naman ni, di ba? It was given on kanang sa slide 10. But diri, sa example, I just wanted to show you nganong naabot siya dira nga kuan. Nganong naabot siya anak nga ratio. Kay, it's better nga, how things came to be, rather than just memorize the formula. Kay sometimes makonfuse ta, but you can never go wrong if you understand the whole process on how you arrived, or on how we arrived anak nga formula. But yeah, I hope you really make time to to understand this, because this is very important. And yeah, mas it would be easier for you to remember if kasabot mo gyud sa ang process. Okay, so that's it. I'll just give you I just yeah, I'll just give you 3 examples, and yeah, thank you for listening, and have a good day.